Hi everyone, my name is Lakshmi. I'll be presenting my final project topic, which is Spark for ETL. In this YouTube presentation of 15 minutes, I will provide you a brief introduction on the powerful Spark engine, concept of ETL process, and finally a few practical demonstration on how Spark can be used to implement ETL process through a few code examples. Let's start with the Spark's definition. Apache Spark is an open source parallel processing engine developed specifically for handling large-scale data processing and analytics. It can handle both batch and real-time analytics and data processing workloads. As we all know, batch processing is one where you need separate programs for input, process, and output, like for example the payroll and billing systems. Real-time data processing is the one which requires a continual input, process, and output of data. As you can see in this picture, Spark comes with some strong libraries, some built-in modules for streaming, SQL, machine learning, and graph processing. The Spark core is its powerful API environment supported in various languages like Python, R, Scala, Java, and many more. Let's learn a little bit about ETL process. ETL is short for the three functions: extract, transform, and load. Extract function is responsible for extracting data from homogeneous or heterogeneous data sources. Like for instance, in a company's ETL process, like you see in this picture, say you want to extract data from your CRM, HR, sales, finance, all these heterogeneous DBs. Then during transform process, the data is transformed into a proper format or structure for querying and analysis purpose. During load, which is the final stage in ETL process, you load the transform data into the final target, like some sort of database. It could be operational data store, data mart, or data warehouse. Now the important question: why Spark to develop an ETL tool? It is very easy to set up. It is an open source engine, easy to scale. It has strong transformation engines. Most importantly, it is very fast because of its ability to perform in-memory processing. This makes repeated access to the same data much faster. One can perform streaming, SQL-based, and machine learning operations too. And now the screenshot, it shows that apparently the most common Spark use case is using Spark as an ETL tool or to develop an ETL tool. The screenshots here in this slide shows two simple basic examples of Spark implementing ETL stages in just a few lines of code. As you can see, there is reading data from different formatted files, which shows how Spark can be used to implement extract phase. Then you see some operations such as filter, map, aggregate, join, sort, which implements the transformation phase. Lastly, you see the loading the transformed data in various forms, which shows how Spark can be used to implement the final stage of ETL process, which is the load stage. So for the practical demonstration of Spark implementing ETL process, I used two different data and two different use cases. One was just a text document which showcases how you could ETL with the help of Spark RDDs, this is the use case one. There is this ulysses10.txt document. This contains some words like afternoon, night, morning. In this problem, I'm using RDD API. Also, I'm demonstrating it in two ways. First, by creating a lambda function which will test whether a line contains any one of those three words. Second, by creating a named function that returns true if a line passed to it contains any one of those three words. I also demonstrated the count is the same. Like all these small exercises, I used PySpark and Spark Python API for this. This shows few lines of code from my application and some sample output. The next use case, in the other use case, I'm using customers transaction product CSV data and showcased ETL using Spark data frames and Spark SQL. So the use case 2 is like it has transactions text and products text documents. Each line in transaction text contains a transaction date, time, customer ID, product ID, quantity bought, and price paid. All these delimited with hashtag sign. Each line in file products text contains product ID, product name, unit price, and quantity available in the store. The idea is to bring those data in Spark and organize it as data frames with named columns. Using data frame methods or plain SQL statements, I came up with a small exercise to find 5 customers with the largest spent on the day. Another exercise to find the names of the products each of those 5 customers bought, and another exercise is to find the names and total number sold of 10 most popular products. That's about the use case 2. The next few slides show sample lines of code and output from the program for use case 2. You see some extract phase and then the output. In this last slide, I took the opportunity to share some of the success stories of Spark, like few companies which have actually used Spark to develop their ETL tools. Like if you see Uber, there are more examples in this link. If you go to this link, I shared these 2 for this presentation. Uber has developed their ETL system using Apache Spark services. Subsequently, the restructured data was stored in an OLAP warehouse using Spark SQL. And then the eBay, main use of eBay Spark is in the field of big data analysis. At the same time, analysts are developing the analysis jobs in Scala. These jobs are then executed through a Yarn container on a Yarn virtualized Hadoop cluster and can accordingly use an adjustable amount of memory and CPU cores to execute. Apart from that, Spark on eBay is also used in conjunction with Shark to improve Hadoop SQL performance in several application areas. And these are the few references. I use some references online and from the lecture notes, and that's the link to my long YouTube video and my short YouTube video. Thank